Okay. Great. So some announcements. I posted two homework assignments, 6 and 7. 6 is for everybody, and it's the battleships that I talked about for a long time, and it's due next Wednesday. And homework 7 is optional. Anybody who likes to do it can do it. Is optional for everybody, and the point is that if you feel unsatisfied with your grade, you can do it and maybe get a better grade. So I posted on Piazza the rules for it. Essentially, I will compute your average with and without homework 7. You know that I dropped the lowest grade, right? So I will compute all your homeworks excluding homework 7 and all your homework including homework 7. For each one of the two series, I will drop the lowest grade. It will be some fun spreadsheet, engineering. And then I compute the average, right? And the highest of the two averages will be the one that is used. So you can do no harm in doing homework 7, but you don't need to do it if you did do well in the others. I think it's kind of interesting, actually. So I ask you to implement battleships, but in Android instead of in Vue, so that you can have, a comparison. If you are like the people on Piazza who felt, nostalgic about Android Studio, then you can be happy and try your hand at it. And in fact, maybe it works really quite well. I'm sure that it works quite well. You have to take care of more of the details yourself, but other than that, I'm sure that you can do a very nice game there. So there will be another homework. The assignment will be about graphics and animation, as I mentioned. So there are many ways of doing graphic and animation. I'm essentially giving you the basic way, which is to do it just in Java, okay, without using any special game engine, without using any special environment, or without going to the native development. There are many other alternatives to do it that are sort of more advanced or use setups. But this is useful because it's useful, I think, more than for producing games. If you want to produce a complicated animation game, you may want to use a game engine such as Unity or these kind of things that really give you a very nice way to focus on the physics of the game and not so much on the programming of the game. But if you want just to build animations that are part of an app but are not a game, for example, I don't know, needles that move to indicate a quantity and then bounce around and show the right quantity. We will build a compass that turns and settles to the right angle. You can build, things that scroll, progress bars that do whatever they want. These simple type of animations. You may want to do them in Java, which enables you in the end to communicate with the rest of the application in an easier way. You are, in the same environment, so this all works easily. And so, so there will be a last homework on that. And I still need to put up the sign-up form for the project presentations. Okay. Sorry if I'm a bit raspy, but I tried to get water before getting in the classroom, but they were out of it somehow. But they had only hot water. If you get me a glass, it's great. Otherwise, I may take a small break later. I always get thirsty when I talk for some time. So what I want to do now is, thank you. I really am babysat by these. So what I want to do is talk about how to do custom views and drawing, okay? So far we have seen essentially view classes that are predefined that we use and like, hopefully we like. But there is, for instance, the text view, there is the list view, there is the edit view, there is, we haven't used it in class, but if you needed to display an image, there is an image view, and so on and so forth, right? And there are also other things that are view classes, but that are essentially layout classes, like linear layout, that have the role of organizing what is inside, okay? So all these classes, essentially, are predefined, and they have a certain behavior. You can customize them to some extent, but what do you do if you really want to build your own class that may contain drawings or may contain special stuff, okay? So to do this, you can create your own definition of a view class. And broadly speaking, you need to care about three things. One is, you know that you use views by using XML. So how do we define how the view can be inserted in XML? This is a part on which I used to spend more time in this class. And nowadays I find it a little bit boring, because I think that this is useful if you want to define a class that a lot of other people will use. So this is important essentially for Android framework developers. But if you build your own class that you're going to use maybe once because you need it in that particular spot of your application, but you need to draw on it, you don't need to make it super nice to include and define everything via XML. You can define stuff via code and it's just the same in the end. So I will still cover this portion, but it's not the sort of main focus. The other important thing instead is this. How things are drawn on the screen. I mean, how do you decide where the thing is laid out? And that we will do a little bit of it. I mean, we will talk about the algorithms and the methods that are associated with that. The last thing that is the most interesting is how do you draw, okay? And once you know how to draw, and we talk a bit about threading, we will be able to do animation. So that's a general scheme. So before I start, are there any questions on the class or assignments or anything else? Okay. So how do you build a new view class? Well, you subclass the view class. So this is an example in which we are building a pie chart view. So a view that will draw a pie chart. Okay. So we say that we build a public. We have a class pie chart. It has a public constructor. And it needs to have this signature. You're sent a context and a set of attributes. Essentially, the context, you know that the activity is a subclass of the context. The context is this holder that contains all the permissions to draw on the screen, the access to the screen. I mean, it's essentially these, how to say, the context object is the object that contains your connection to the fact that you are actually the activity drawing on the screen and contains all the other data. How did you get it?
I have to go upstairs and
Oh, wow, I didn't know. So, I can teach Android and not obtain a glass of water, it seems. That seems to be the upshot. Okay, so when you define a new class such as PyChart, you can make it usable from XML, and I have a few slides on it. So essentially you need to write some declaration in res values attrs.xml. So this is a file where you can define attributes that are stylable for a new view class. This sounds very complicated, but we are designing a new view class. We need to make so that we can change its attributes from the XML layout file, and so we need to declare what the possible attributes are. You know that when you're in Android Studio, if you use a text view, you have various attributes, and you say Android : and then I don't remember the name, but for example, uppercasing is equal to true, no? So all these attributes are declared into the Android internal equivalent of this file, and if you want to do it for your own class, you have to add them. So here we are adding two attributes, an attribute show text, which is Boolean, and an attribute label position, which is an enumeration that has two values, left and right, that are internally translated to values 0 and 1. Okay, and this is for an XML class called PyChart. So that's what happens behind in order to be able to define attributes in XML for your class. So once you do that, then we are able to use the class from XML. The one thing we have to do is this. So we need to do two things. Maybe it would have been better if there was a line break here. But we need to do two things. One is to say that now we are using, in addition to the Android namespace, which is defined above, XML namespace Android is due to these, okay? And the XML namespace custom, okay, is instead related to our applications. So COM example custom views is the application that I'm building. Other application I've built for the class are called COM del Faro or something, right? So essentially we have to declare the XML namespaces whose objects we are using. I mean, whose classes we are going to use. Okay, so it's important that this line is here. Because when we use our our special pie chart, instead of, normally you have used something like a text edit or linear layout or this kind of stuff, no? So you use simple names. Why? Because the layout builder has those names already imported and it knows about them. If you use your own custom class, you have to use a fully qualified class name. Okay, you cannot use a short name that you would use in code. You have to use a fully qualified with your domain, etc. So here we have to use COM example custom views charting pie chart. No? This is essentially the package name, I mean, the whole path to the Java class that you plan to use. Okay? And then you see, because we are using the namespace, oops, sorry, I forgot that if I click it advances. But since we are defining the custom namespace as the one for our class, we need to preface these things with custom and then say show text and label position. Okay? So, I mean, to me it's all a bit overcomplicated, but unfortunately that's what we need to do. Okay? So it's just, I mean, the technical name for this is boilerplate, right? So it's the stuff that you may wish to understand and you can understand, but if you don't understand, you essentially monkey it and it kind of works. Okay? So the key idea is to remember the fully qualified name and to define this custom namespace. You can call it custom, you can call it whatever you want, flower if you wish, But as long as you use something that is not the Android namespace that is generally used. Okay? Now, when you create your view, how do you use these attributes that are specified in XML? And again, a marvelous example of overcomplication, in my opinion, okay? So now the constructor, you can change it to these. Before the constructor wasn't doing anything. I mean, it was constructed in the class, but it wasn't looking at any arguments. If you do want to look at the arguments, you have to look at them in this way. You have to say, I want to get a typed array A, which I get from the context, I get the theme, and I obtain the styled attributes. Attributes are stylable pie chart 0, 0. So this stylable pie chart, by the way, this line here, okay, refers to this definition, right? Here in atros.xml we have defined that pie chart is stylable, okay? And so that is what this R stylable pie chart is. It's the type for the possible attributes. And 0, 0, I don't know what they are. But they're a small thing. No, just kidding. Okay? And then in a try finally group, you do this get boolean and get integer, in which you use the label names and you give a default for what to get if the values are not provided. So you can define your default values there. Okay. So after a long time and effort, we are getting these two pieces of information: a boolean and an integer. So once you do your effort in order to extract those two attributes, you have to say a.recycle. Okay. So evidently, a typed array is an expensive thing to produce, and so again, rather than throwing it away, you want to try to recycle it. You know, this is like you are using a language with a garbage collector, but you don't quite trust that it actually works well, and so you do a bit of the garbage, you help it a little bit along the way, you know, this kind of idea. Okay. You can also create, obviously, getters and setters. I think this is quite obvious, okay? So, because you're defining a class, you can define methods that change values of variables of the class. Big deal, of course, right? So, we can say set show text, which is a boolean that tells us whether we have to show the text. Okay? So, the only point is that if we, and this is a common thing, that was, you know, surprising to me when I learned it the first time, but maybe obvious to a lot of you working in games. When you make changes that alter the way the thing is drawn, how do you cause the thing to be redrawn, right? So suppose you make a change and so the content of the view is altered in any way. So the way you do it is this. You give an invalidate. That invalidate command essentially says, my current rendering is no longer valid and it needs to be redrawn. Okay? And this is not actually a very discriminating command. It's not like Wu that tries... Wu is like a gardener, you know? There is this big tree of HTML elements that are laid out in the document object model. Wu detects a change on one portion of that tree. For example, you add an element to the list, or you change a cell content in your tic-tac-toe, and Wu, like a gardener, you know, snips the right node out and puts the right node in the tree and tries to do minimal change like somebody who's tending to a tree, no? Which is what it is doing in the end. Instead here is like, I don't know, a steamroller approach, right? The view is no longer valid, crash. They just redraw it from scratch, okay? Nevertheless, it works fairly well, even for simple animations. Okay, so invalidate causes the view to be redrawn, and request layout even can cause the layout to change. You need to call request layout only if you want the layout to change where the view is. For example, if elements in it change size. We will see that in animation, we will typically only ask for invalidate because we want to animate the content, but we don't want to change the size of the view itself. Okay, so that's the difference. Now, if you wanna put stuff in the actual view, so you know what is that you invalidate and how is the view rendered. So the view has a method that is called onDraw. The view has two important methods essentially to render itself. One is called onMeasure, and we will talk about it later, and the other one is called onDraw. OnMeasure essentially decides how big the view is so that it can be laid out, so that it can be assigned a position on the screen. Okay? And instead, onDraw draws the content of the view. Once, you know, the call to onDraw happens after the one to onMeasure, okay? Because onMeasure is done during the layout. So, it's called every time the view is redrawn. So there are a few tricks. So when you draw on a view, I think this may be familiar as an approach to people doing games. How many of you are in the game major, by the way? Not a lot of you. Okay, so but if you feel like injecting your wisdom, do, because I'm not a super gamer myself, or super expert in graphics for games and the like. So feel free to inject your wisdom. But when you draw, you essentially create various objects. You create paint objects that are the objects with which you draw. The paint objects contain the color, but also contain the aliasing that you want to use and a lot of these properties. These are generally expensive objects to create, and so you want to create them once and for all for the class, okay, and store them. And store them in the initialization of the object. You store them somewhere, the paints with which you want to paint. And so in onDraw, you just want to use your already defined paint objects to draw again on the canvas. Okay, that's the idea of what you do. The canvas uses the painter's algorithm, which is a very nice algorithm for what comes later is generally on top of what's before, okay? So these, if you want to superpose things, that's how it works. So this is how you can create paint objects. You do in the initialization method, okay? You say, this is my new text paint, which is a paint with an anti-alias flag. I can set the color. I can set the text, I can set the text height. I mean, you can look at all the documentation for the various attributes that you can set, I guess, for a paint. No, you can set the style, whether you should you should be filled or not. You can set the text size again. They have mask filters for the shadows, etc., etc. Okay, so I'm not gonna cover in incredible details all the various paints. Okay, I think this could be a large topic, but essentially I'm gonna teach you paints by examples. Okay, by showing you at least how to draw text, lines, and circles, squares, etc. And then from there, if you want to draw more complicated things, which will not be required for the homework, but if you want to draw more complicated stuff, you have to look at the documentation at some point, because the possibilities are just too large. I mean, it would be kind of I don't know how to teach you these things that have a lot of documentation attached. I mean, the concept is that. Okay, so to say how big you want the view, you override the onMeasure method. So this is kind of interesting. Imagine that you are. So this is one of the things that in which Android is done in a nicer way than HTML, in my opinion. They have much more control on how things are laid out, much finer control. So imagine that you need to lay out things on the screen of the Android application. Okay, how do you do it? Imagine that you're the person writing the algorithm. There is a tree, right? Because you have defined in XML the tree of stuff that you want to put on the screen. And so now you must go somehow down the tree and figure out where everything is, where everything belongs, right? And you can imagine that as you go down the tree, there is a sort of recursive algorithm that, obviously, being a tree, that goes on. Essentially, at the top you have the whole screen. You have a view that is your child, and you're asking that view, please view, this is the max size that you can be. No, this is what they told me that you have to be. For example, do you have to be exactly this big? Do you have to be at most this big, or can you be whatever you want to be? No, this is what you have to be. Lay yourself out, and then at the end set your size. But this is what the constraints that I have due to how everything else is laid out. Okay, so suppose I have the root does this, and the root is say a linear layout that has two children. No, these two people there. No, and so once I have the two children, then I go first to the first child and say, hey, how big would you like to be? And he does all the calculations, and then he will set his size to be 30 pixels by 50 pixels. So, and then I will know before I call the other person, how much of layout is used by that. Okay, so we don't see some of the recursive calls because the recursive calls happen for the layout type of classes, that are in charge of managing the position of the children. What I'm teaching you here is how to write these onMeasure methods for the children that are the leaves of the hierarchy, right? So, things like a text view or this view or a pie chart view, they are the leaves because they don't inside contain any other view, right? So in the case of a leaf, you are told how big you can possibly be and whether that has to be exactly at most or unspecified. You do your own calculations and then in the end you set the size that you actually are, okay? And then your parent will use that in order to inform the other children while traversing the tree of what is the space that they can possibly occupy. And so when the tree traversal is finished, every class has exactly, every view class has exactly the size with which it is laid out, and kept not by you, but kept by Android. Also, the absolute position in the window and the view and all this kind of information that is used, to control the GPU-based layout, essentially. Okay? So that's the general picture of what's going on. So what you do, this is an example of how to write that code. Okay? This is a non-measure method in which we are given a width measure specification and a height measure specification. And so what you do is something like this. You get, for both width and height, now this may be your wish. Suppose that if nobody told you anything else, you would like to be 100 by 100 pixels. But now you want to listen to how much space you are given, and whether you have to fill it in all or max or min or what the mode is. So this is your wish, and this is instead what you are given from above, the width size and height size. And this width mode and height mode are these exactly at most, or what is the rest, unspecified, right? So you have specifications for how much you should fit. You know that when you create views in XML, you have these wrap content versus fill parent, right? This is exactly what is translated to. When you have a fill parent, this is translated to an exactly. Because if the parent is 500 wide, then you have to be also exactly 500 wide. You cannot be smaller than that. If you have wrap content as XML type, for how big the object is, then this will be translated to an at most, in which you tell you, 500 is how much space I have, but if you want to be smaller, fine. Okay? So these are is where it corresponds. So now, width and height are what we will actually be. And so there is this code that, this is sample code, but is very often done in this way. So it works in this way. If they tell me exactly how big I should be, then I listen to it. Okay? If they tell me at most how big I should be, then I want it to be the minimum of how big I want to be and and the constraint. This is essentially, I should add comments, but this is essentially fill parent, and this is essentially wrap content. Okay? And if they don't tell me anything else, if nobody tells me anything better, because suppose inside a scrollable view, you can be as big as you want because the view itself is scrollable, right? So if nobody tells you anything else because you don't have any actual physical constraints, then I'm gonna be as big as I wanna be. Okay? And you do the same thing. This is for the width. You do the same thing for the height. Okay? You can also do width and height. You can also process width and height in parallel. Jointly. For example, if you want to force your view to be square, right? You don't need to do this separately, obviously. But this sample code tells you at least, one way of doing it. It sort of gives you the idea of what's going on, okay? And then you call set measure the dimension and width and height. So this is fundamental. If you don't set the measure the dimension, I think you get an exception. Okay, I'm not quite sure. I don't know if otherwise you get some default, but clearly you don't get what you hope you would be getting. Okay? So canvas is what you draw on, paint is what you paint with. So this is an example in which we are creating some paints. And then we draw. We draw in the onDraw method. In the onDraw method, you have passed the canvas. Okay, you don't have to create a canvas. The canvas is, Android is creating it for you. And when there is an invalidate method, or at the beginning, the first time, this onDraw is called with the canvas of the appropriate size on which you should be doing the drawing. Okay? And so you draw in this way. For example, you have many methods of canvas to draw. You have a draw oval, draw text, draw arc, draw line, draw circle. You can go read the documentation, but all the sort of semi-reasonable things that you might wish you would be able to draw are likely to be there. Okay, yeah. So, for example, for the text, you need to get, the text. Then you have the two coordinates of the text, and then you have to specify with which paint. Okay. If you wanna, if you wanna draw the pie slices, then you iterate over the slices. For each one of them, you set a shader. For each one of them, you take the paint, you set a shader. And then you draw an arc, and you use the pie paint that you have defined before. Okay, to draw a line, there is you can have some text. There is and then there are the. Wait, I don't remember where I did this. It's simple. Okay, this is X, Y, radius and color to draw a circle, okay? I forgot, this is a fake example, essentially. We will see a true example later on, okay? So I'm not sure exactly of how these things work now. I mean, I recycled it from a very old example, okay? So these are some of the things you can do. You can draw paths, bitmaps, and many other things. Okay, invalidate I told you already, and this is the end of the slides. So now that this is the end of the slides, there are two things that I would like to show you. So one is this. So there is a very nice tutorial that is written fairly well. Part 4, part 3, part 1. So this would be the right order in which to go. So there is a very nice tutorial on how to do an animated view. The thing that you do in the end is you draw a line that can actually that you can redraw, that you can change dynamically the points, and this line smoothly adjusts to the new position. Okay, so this is what this tutorial is doing, and I would recommend it because I feel a bit strange, going over the tutorial in class. I don't want to go over these web pages because it's very distracting, but I will be posting the links, and I think you should really read the way it's described because it's very well done. I found it very helpful myself. I was reading these many years ago. This is a bit old, in fact, 2012. I think that was around the first or the second time I taught this class. I was learning myself how to draw and how to do animations, and this tutorial was really quite helpful. Okay, so I will post it among the resources, and what I want to show you is a little bit of the code. Okay, so I need unfortunately to open these various pieces of code in Android Studio, and I need to find them first. 1 second only. They are in my teaching Android directory, and they are okay, view tutorial part 1, part 2, and view tutorial all. So let me maybe begin from the part 2. 1 second, view tutorial, part 2. It takes just a second. And then it starts complaining. It's still building it, okay? So I need to wait a second before I... Any question, any comments so far? In general it works, so I wouldn't be so... at some point it will work. Okay. Yeah. As I told you, I'm much happier with Android Studio this year than at any point in the past. It seems to be much more reliable in building than any of the previous years. Okay, so it seems to be ready to run. I need to start my emulator, okay, so again 1 second, but it won't take long. Okay, maybe my laptop gets a little bit slower when I both record the video and try to do all these. Come on. Oh. Maybe I should close some applications. But we're not going to use PyCharm. Okay. Okay, so this is what we are going to draw now. So there is no animation yet, okay, and we just draw a line chart. So let's look a moment at the code for drawing these. Let me show you first the structure of the application. So this is exactly the code that this person wrote, that I imported, and the class names got changed into Comme de Alfaro Luca. I don't remember why, but essentially it's his tutorial, not my work. So this created by Luca actually is not actually true. I maybe should remove it. This is one of the things that was created automatically by Android Studio. I never write comments in that way style. Okay, so how does this work? Well, there is a main activity and a line chart view. The main activity is super simple. It simply gets, using find the view by ID, it gets a reference to the line chart view, as we have done all the time for finding the reference to a text view, etc. and then it calls set chart data, in which it simply sets some random data, which is actually not random, okay? But it simply sets some data to the view. So the main activity basically doesn't do anything. Now, the layout is slightly more interesting, okay? If we go examine the layout, we see that in the layout there is a linear layout that contains the line chart view and then some text view below. You know, the text view below simply says line chart view, which is, you know, not a very deep thing to say. And this is the line chart view. Okay? So how do we define, by the way, notice that here out of sloppiness I'm using the Android namespace even for my line chart view. It probably shouldn't be done in this way, but the tutorial was doing it in this way, and so I followed, okay? You see, we can define some attributes here. So let's look at the implementation of the line chart view class, which is where all the action is. By the way, I just want to underline that if you want to create a layout like this line chart view over here, obviously you cannot drag and drop it into place, right? Because it does not exist among the things you can drag and drop. At least I believe it does not, unless they have changed the layout to somehow know about your custom classes. This could happen, actually. Let me see. Let me see if there are some classes that are due to you. I don't know whether it would be in advanced. No, these are only the standard classes, okay? Sorry? Yeah, let's see. No, it doesn't seem to. No. For example, I think you would find the text view. Well, I am searching Google, right? So let me try to search for no. Yeah, so you cannot drag and drop it, okay? You have to define it, to insert it yourself. Even I mean, they could implement it, I guess, but they haven't. Okay, so line chart view is where all the action is. Is this readable or too small, the font? You sitting in the back, is it readable? Okay. So what you do is this, you define a few constants, etc. This is the initializer, public line chart view. Okay, and what we do here is nothing. Okay, so we essentially don't do anything with our special attributes. In the layout, these are classical Android attributes that are used. No, sorry, these ones are classical layout attributes that are used and that are used by Android as default for what we are doing. But they are not processed by us. So what happens here, is that you call, where is that you do it? You call super of context and attributes. People are setting some Android attributes, and we simply pass them to the Android view class that we are extending. Okay, we are not going to deal with them. We are not defining any special attributes of our own, because our only interesting method, which is called the set data, will be done programmatically. Okay, the only interesting operation will be done in that way. So set actually is called set chart data. Set chart data, what does it do? It sets the data points and then it invalidates. By invalidating, it's triggering a redraw. Okay, so there are then the two methods that are important: on draw and on measure. Let's look at on measure first. Where is on measure? Okay, there is no on measure. Evidently, they decided not to override it, to just use the default layout that would happen. Okay, so you can override it, and we will override it in another example we have. But here they don't. So there are two methods, draw background and draw line chart. The background is essentially this sequence of dark space with the 4 lines, and the chart is the blue line. So for the background, you do essentially a loop in which you draw many lines. Okay? The only computation that you need to do is the one in which you need to find the extremes of the lines. They go from 0 to y pos. Y pos is this variable that you do it in this way. So the problem is always that you need to know when you draw something how big you ended up being. Okay, and so you have these various methods that enable you to compute the area that is actually drawable. There is a get height method, okay, and there is a get width method corresponding. There is a get padding top, get padding bottom, and get padding left and get padding right. So essentially you are trying to compute, how big is the region in which I can actually write. And the region in which you can write is, the height and the width of the view minus any padding that you might have on the 4 corners, on the 4 edges, okay? So you do this math in order to compute what the max value is. It's the height minus the 2 paddings. So the max value that we can have for the for the y position, and then okay, so get y pos is used to translate a value in your. Here comments are missing. Maybe I should add them. Translates a value as you think at it in the chart into an actual pixel position. Okay, so this is what this is doing. So first you are trying to determine how big the view is, and then you scale the value appropriately, and you re-add the padding so that it will be shown in the right place. Okay, and so get expose is same for hori values. So essentially, these two functions are used to translate between the numbers in the, as you think of them in the line chart in the plot, to the pixel positions on the screen. Okay, taking into account of all the paddings. Okay, so let's go back to the drawing. You see, what this is doing is this. It's saying the max value is the max value of the data points, and then it is doing a simple loop in which for y is equal to 0 to smaller than max value, it is actually drawing horizontal lines that go from 0 to y position. So from 0 y position, which is the position of the y in pixels, to the width that you should be using and y position using the paint. So it's drawing essentially the horizontal lines. Okay. What else? Then you draw the line chart, and for drawing the line chart, the interesting method, the interesting idea is this. That instead of drawing many segments, we draw a path. So a path, is an object that has many. Is like how it is called, a piecewise linear line, a piecewise linear segment, something like that. So, so you can create a path, and then you can add various segments to it. Okay. The reason why we like paths is that you can do various things with paths. For example, you can make them look smoother. Via by declaring that they should be, smoothed with various algorithms. So what you do is this: you take your path, you say that you initially move it to get x position 0. So we assume that the x's are uniformly numbered 0, 1, 2, 3, 4. So get position x 0 is telling us the pixel position of the 0th point. Okay? And get y pos of data points of 0 is giving us the y coordinate in pixels actually of the first point that we want to draw. Okay? So this is where the line starts. Okay? And then we loop over all the subsequent points, and we say path line 2. This adds a line from the end of the path to these new coordinates that are simply get x position of I, get y position of data points of I. Okay? So this is, these ones have the coordinates on the screen of the next data point. And so we do a path line 2 from the previous point to the next one. Okay? And so this will draw the path. Okay? Then we take the paint and we draw the path with that paint. I'm not quite sure, to tell you the truth, why he is doing. This is done in the tutorial. Maybe he mentions it, but I'm not quite sure while he does all these operations of setting the paint properties over here, rather than doing them once and for all in the class initializer. Okay? I think it's simply for brevity. I don't think there is a big performance hit, but I think the style manual, so to say, of drawing would tell you that the more of these paint operations you do in the initializer and the fewer of them you do in actually the animation or the drawing, the better it is. In this case, it doesn't matter to him because he's drawing only once, right? But if you were doing an animation and calling on draw many times, this might have some performance effect. So maybe all this code over here would have to be moved to the initializer, not this line. This line is the important one, okay? Because it says, hey, canvas, draw this path using this paint, okay? So you essentially, you build the paint, you build the path, and then you tell to draw the path using that paint on the canvas. That's the way it works, okay? So this is step 0 of the tutorial. Are there any questions up to this point? So what I would like to do is to open the tutorial after we had animation. It takes a moment. Actually, it takes less than before. Okay. So let's run this version of the application. It's building it. So I want to show you the behavior before I describe how it is done. Okay, so this is the application running already. So we have 3 buttons on top, and when we press the various buttons, the curve and the background change shape in a smooth way, even with some bounce. Okay, so I'm not exactly sure that this is sort of the best animation. Maybe my computer is running a bit slow, and if it runs faster, it's more pleasant for the user. I would sort of get impatient. But I think, in fact, on a real phone, this happens quite fast, and it gives a sort of pleasant, smooth effect of transitioning from one curve to the other. Now, the point is not that, this is a marvelously important animation to be able to do. But I think that the point is that, how would you do animations like this? What is the general principle, okay? And so the idea comes out of a comparison of the 2 pieces of code. So let's look at how the code used to be and how the code is now. So in the old code, this is yet another app that we will not be talking about today. So in the old code, this class, the line chart view, had an array of data points. Okay? When you set the chart data, you set a value to these data points, and then you invalidate. When you invalidate, this knows how to redraw itself. Okay? So this is what went on so far in this. And the idea to do the animation is pretty similar. So the idea is as follows. We will have an array of things that tell us what to draw. Okay? In this case, the array is of constants and nothing moves. In the new version of the application, the array will somehow change. Okay? Once we have the array of things to draw, we will know how to draw it. Okay? So think at it this way. The invalidate method knows how to draw the view. Okay? So suppose that we can achieve 2 things. One is that we can call the invalidate method frequently so that we can get frequent redraws. And the other thing is that we can obtain is that at each redraw the values are different, creating the animation. Can we do something like this? So essentially we split the job in 2. There is the onDraw method that will draw the current values of what is in an array. Okay? So the drawing part is done by onDraw. And then we have to invent another part that tells us how big, where are the stuff that we should draw. Okay? Fine, eh? And so we do it in this way. Here we have an array of floating point numbers. In the new version of the code, we will have an array of objects. So we transform each fixed floating point number, that is a number that, fixed, obviously, right? We will transform it into an object. Because, the point can change. It can go up and down, for instance, no? Can change value. In your homework, the point may be, the position of a ball, right? That it can be fixed when it doesn't move, but otherwise it can move, right? So these points that are floating point now will become objects. And these objects will have a method that is essentially, where are you? Okay? So what's your x value and what's your y value? What's your position? These objects will have a get pose or maybe get x pose and get y pose. It's your decision, Maybe it's easier to do get x pose and get y pose. But essentially, these objects will have a method that will tell us where they are. Notice that if I take this code and I replace it in a stupid way, I create an object that contains a floating point, and that's all it does, and it returns it when you call it with the method gets y pose, I would be able to exactly replace this code with an object-based version and have no change at all. And perhaps we should do that, okay? But it's clear to you, right? I would change these private float data points in private fixed objects data points is equal to new, array of those objects. And then I would simply fix the position of each one of those objects to the position where they should be, and they would have a get position method, right? So I can do this change, and nothing would move, and everything would work exactly as usual, okay? But the idea is this, that instead of an array of fixed floating points, I'm going to have an array of objects that have a physically defined dynamics. Okay? I can set their initial position, for instance. I mean, normally you always set the initial position of stuff, otherwise you don't know where it is. But then you describe in terms of essentially differential equations that you solve for the computer, but you essentially you define in terms of passage of time where the object is going to be, according maybe to the interaction with other things. Okay, so this object will be transformed into I mean the tutorial author and I then as consequence call these. This class a dynamics object, okay? And these dynamics objects will have two methods. One to indicate the passage of time, update your position by where you will be in 10 milliseconds. And then they will have methods that say, what is your x position now and what is your y position now. You can add other methods if they are useful. For example, what's your state? I mean, imagine that you have a ball that can break, and then you want to ask whether it's still whole or whether it's broken. You can have other stuff, But the minimum to move things is to define these objects that have a time passage method and a position method. Okay. So before we look at the code, suppose that instead of having an array of floating points, we have an array of these dynamics objects that they can move. How does our code look like at a very fuzzy level? It looks like this. We initialize the positions of these objects, and then they will start moving. And so we go through a loop that says essentially, please, I want to run 20 milliseconds in the future. It's your choice of how fast frame rate you want to have, okay? And so you ask, please, let me run 20 milliseconds in the future. And when you run, you say two things. First, you go over an array of objects, and you tell each one of them, hey, 20 milliseconds have elapsed. Recompute where you are. And these objects need to be able to compute where they are after 20 milliseconds. Okay? And then you invalidate the view. When you invalidate the view, you will go through the classical drawing on draw method that draws the screen, that instead of using the fixed position of the objects as we did in the previous instance of the code, it will instead ask each object where it is to draw it. That's it. So the difference is not very large in the code actually. Okay? So let's look a moment at the code for how it was before. What are the key pieces? You see there is an array of floating points over here. Okay, we can set these floating points, and when we draw the floating points, leave aside this draw background. Okay, this draw background, I will not focus on it. You can look at the changes, but what I'm more interested in is in this method of drawing line chart. Okay, so what we do is this. You see, we say data points of I. You see this line, which is a sort of fundamental one. Okay, this paints a line to the height of the ith data point. It does not ask, it just extracts the array value because this is an array of floats. In the new version of the code, this line needs to be replaced by asking the ith object where it is. Okay? So let's look at the new version of the code and look at the delta between the two in this way. Okay? So the new version of the code has a notion of a dynamics class. We will look at it later, but let's look at the difference. Now, data points is no longer an array of floats, but is an array of these dynamics objects. Okay? Let's look at the rest later. Let's look at the key point where we draw. This looks a little bit different because they want to draw a smooth path. Okay? So the code is more complicated on the surface. But the key piece is this. Yeah, I'm sorry. No, maybe I should have modified the tutorial to animate a straight line graph in order to make. But this is not what the original author did, no? So I mean, I kept it consistent to the web pages so that you can read the web pages after you listen to the class. Okay. So essentially, you see, before we had the data points with I, and that was the height of the ith point. Now we call get position. Get position will give me the height of that data point at the current time. This is because our points are moving in a line, okay? So we don't have like get position x and get position y because, because there is only a y and they decided to call this method get position. But in the homework assignment, I assume, I mean, I haven't decided the full details yet. I think I'll assign it over the weekend. But I'll assume that the object that you need to have moving will have both x and y positions. And so you will have a similar code, but instead of just saying get position, you will have get x position and get y position, something like that, okay? But so you see, the change in the rendering code, in the on-draw code, is very minimal. All we do is we replace an array of floats with an array of dynamics that we need to ask for their value. Okay, that's the whole there is to it. Okay, and in fact, if you look, except that the author of the tutorial went to smooth lines, so that creates more code because you need to create these control points to have the smoothness of the lines and yada yada. You can read in the tutorial. I'm not very interested in teaching you how to draw splines. So if you want to read about that, I mean, the tutorial is very well written. I think you should read it. Okay, and so I don't want to repeat this in class if you can read it so well. Okay, but instead what I want to focus is on this. Dynamic portion. So this is the only difference that there is around here. Okay? So the other points are two. How do we get something to run at regular intervals? Okay? And how do we build these dynamic objects so that they encode the dynamics with which every point moves? These are the only two remaining problems. Is it clear so far? It's a very neat change, right? Because the guy essentially first developed the code for nothing that moves, and then simply replaced an array of floats with an array of moving stuff. So let's look at first how to make, how to schedule the movement. So to schedule the movement, he has at the beginning this animator class. Okay, so this is a runnable, which means it's a class that has a method run that you can override. Okay, so I'm not sure I'm able to finish today this whole part. I think we will go over it, some of it next time as well. But the idea is this. Every thread in Android has a way to which you can pass to it. This is a very important concept, and we will go to it many times in the future classes. You know what a thread is, right? A thread is something that can run and execute code. Okay? You know that Android is event-driven. So the UI thread is generally there sitting doing nothing. Okay? Then you poke a button or you poke the screen and the UI thread says, oh my goodness, I have to do something and redraw and transmit the click or do something, right? So every thread in Android is reacting to events and has essentially a sophisticated event queue that the details of which we will examine in the future. But it has an event queue at the beginning. I look at it, the thread as, to me, the mental image I have these weirdly mental images, I have to tell you. But to me, a thread is like, this sort of worm, with segments, no? That has this big toothy mouth, okay? So every thread has, it's not meant to be a nightmare, by the way, but every thread has the body of the thread and then has this sort of ingestor to which you can pass stuff to run. And then it munches and runs it. So it has this ingestion part, okay? It has essentially this event queue that is very sophisticated. You can tell it to run stuff now, or you can tell it to run stuff with a certain delay. Okay, so it's not a dumb queue that what you put in gets done in order. You can define when things should happen when you put them in the queue. And we will talk later about the details of the queue and all the beautiful things you can do with the queue. But in this case, all we want to do with the queue, before I tell you how this animator works, is this. Oh, actually, here he does not use any delay. Ouch. Okay, it's maybe not the way I would have written it. I would have first a certain delay. But so what he is doing is this. He's using post animator. And this post method is a method of the current thread, and it posts a runnable to run. It essentially posts this animator inside the queue. Okay, it takes the animator and it throws it in the mouth immediately with no delay. I would have used a delayed post because if you do it in this way, you are giving too much food all at once to the UI thread, right? It's kind of a waste. I mean, you don't want to redraw as fast as possible. You want to redraw with a delay of maybe 20 milliseconds, 10 milliseconds, something like that. So I would have used a slightly different method here. You see runnable action added in API level 1, but I think there is a see also post delayed, runnable long. So I would have changed these, and we can change it in a moment, in fact. Let's try it. Post delayed. Okay, and we can add a delay which is in milliseconds or microseconds. Milli? Milli. So what do we do? How many? 500? So that we see a bit of the effect. So if we run it in this way, let's run it. Why there are errors? It's just an error in the doc string. No doc string. It's just Android Studio complaints. 1 second, okay? Okay, now if I press here, it's still smooth. Why? Was this the only call to post? Okay, let me use a longer interval. Sorry? Okay, so let me take a much bigger interval, but also I want to know whether this is the only occurrence of post. Maybe it already had a bit of delay, actually. Maybe this was the main one, actually. Yeah. Hey, wait. Where was I? What post was I changing? Oh, yeah, that's silly. I was changing just the first instance, okay? So fine. They already had a delay. I was surprised. Okay, fine. So, essentially, when you set the chart data, you start to post to the animator that will cause a recompute, okay? And the animator will continue to post itself if there is a need for a new frame, but with a delay of 20 milliseconds, obtaining a 50 frame a second frame rate. Okay? If we change these, this would give us a slower frame rate. This was the one to change if we wanted, okay? Yeah, okay, now it works in a stepwise fashion, okay? Fine. So let's put it back to 20. So, what does this animator do? Okay? When you run it, so you don't want to run the animator forever. You could be doing that if you wished, okay? But in this case, you don't want to do it. Once the line settles to the new position, you want to stop running it, okay? So the way you run this animator is this. You say, need a new frame is initially false. And now I want to do a loop in which I tell all the dynamic objects to please update their position, okay? I compute the time now. I use this animation utilities current animation time in milliseconds that gives you the current time in milliseconds so that you can use it to figure out how much time has elapsed. And then I say, for all my dynamic objects, so I loop over all my data points, which in this case are dynamic objects, and I tell them dynamics dot update now. So I update their position and the internal state to what it should be at this current timestamp, okay? And then I essentially, these dynamics, in addition to the get position, have another method that is called is at rest. So it's no longer moving. This is a particular thing that is useful, especially in this example, okay? Because in this example, once things stop moving, they won't start again. So what I want to do is I want to stop the animation loop once everything is quiet so that I save CPU. That's all there is to it, okay? And so what I'm saying is this. I loop, if the dynamics is not at rest, then I need a new frame, okay? And if I need a new frame, I will post again this. So I post again the animator with the 20 milliseconds of delay, okay? So that is the loop that causes each time a new frame and tells the dynamic objects to update their position at regular intervals, okay? And so the only other thing, we will go next time into the dynamic object, I believe, so that you also have time to read the tutorial. But the only thing that I want to show you now is what happens when you set the chart data, okay? So when you set the chart data, you are passed an array of new data points, no? This one. And what you do is this. Well, you do some normalization. I don't know what exactly what it does or so. But essentially, it creates a new dynamic object. Okay, I mean, it creates actually an array of dynamic objects. Okay, and then it sets each one of them to a dynamic object that has, I don't know what these 1.1 and 0.3 are. I mean, I think I know. These are constants that define how these objects will move. These objects behind the scenes are implemented as springs, no? It's as if, this is a position where you want to pull it to and it does, and then it settles. So being a spring, you have two constants. You have the spring constant and you have the friction, the damping factor. And so these two numbers here are the spring constant and damping factor, and you can play with them. But this is like specific to the example at hand. What you do is that you create a new dynamics object in which you set, its general behavior parameters. If you're modeling a rubber ball, You would, for example, say, you know, how squishy it is. That is, when it hits a wall, you know, how much can it get squished. And you can have the elasticity, so the bouncing factor, you know. If it bounces, with what fraction of the original velocity does it bounce back off a wall, right? You could do these kind of things. I mean, you can do as sophisticated models as you want, but essentially, you create here the objects with the right parameters, you put them all in an array, and then you set, you know, the dynamic object can have many methods as you wish, and so you are setting two things to them. You are setting the position where they are now, and this is almost universally true that you need to do it, because you need to tell them where they are at the beginning if they are to move. And then you also set, to guide their movement, what is their target position. Because, you know, in this animation, you set where things are now, where the target is, and then the position of the object will converge to the target modeling as spring bounds, okay? If you're developing a game of, I don't know, spaceship and asteroids, rather than setting the position and the target position, you might want to set, you know, the position and the initial velocity vector, no? The velocity x and y, something like that, okay? Essentially, we are initializing the internal state of the dynamic objects in the right way. And this is application dependent, right? But as you see, it's conceptually simple. These objects have a state that defines their dynamics when we need to set it up. And once we do this, we do two things. So, there is this if-then that says, if the data points are, if I didn't used to have any data points, or if the data point array vector is different from the previous one, I really don't know how to do the animation. So, just draw the new screen in a single blow. I call invalidate, and that will just redraw immediately, right? Otherwise, if I know how to do the animation, I don't do this. I don't know why it does set target position twice. No, because if I already have an array of data points and I just change the graph, what I do is I set the target position to a new value, and then I do this. I remove callbacks to the animator and I post the animator. Posting the animator means that I ask that the animator be fed immediately to this hungry worm and be executed immediately, okay? But I also want to remove the callbacks to the animator. Imagine that this mouth is really quite big, okay? And can contain delays, okay? So perhaps there was an animator posted that still has 17 of its 20 milliseconds to go before it gets to run, okay? So in general, this mouth of the thread is a queue that has both priorities and the delays for when things can be posted, can be run, okay? So if I want to put a new animation in that will look different because now my target position is different, I want to be sure that any previous animation stops running. I think you have seen an instance of this problem of having too many things running in one of the first homework assignments, right? What was it? The countdown alarm, right? In which if people were not careful, you had multiple versions of the alarm running. Here you can equally well have multiple versions of the animation, because, you know, you can have one running here that generates one running there with a certain delay, but one running here, you know, generates one running there where this is time, no? And so you would end up animating more frequently than you really wish, okay? The problem is not so much one of inconsistency of the animation, because in the end you have always the same dynamic objects and they will get updated always in the right way. The problem is that you're wasting a lot of computation, possibly in an unbounded way, right? Because every time you post a new animation, you don't stop the old one, and so every animation would keep scheduling itself every 20 milliseconds. So what you do is that you say, remove callbacks to the animator, and those callbacks are essentially, it essentially says, please go over your queue of tasks to be done and remove all the instances of the animator. Okay? So this is a selective clean. The queue can contain a lot of stuff to execute. Some of which doesn't even belong to you, you know, is maybe like a screen withdrawals due to other stuff, etc., etc. Because this is a generic UI thread queue. It's an important object. You shouldn't mess with it, okay? But what you want to do is to purge it of all the instances of animator, which you do it in that way. So you first purge it, and then you insert your new instance. Obviously, if you do the vice versa, nothing animates. We could try. Yeah, I don't know what would happen. I think if this was a post delayed, then I'm sure that, you know, but otherwise it would depend on... no, I think that nothing would run if I do this. Let's try. No, we are already out of time. Okay. We try next time, okay? But nothing should run. So I will be posting the pointer to the tutorial. Please go over it, and I will post all the code so you can reproduce these when you like, okay?